The following course of study is on programmed instruction. The purpose of this interactive presentation is to impart a basic working knowledge and definition of programmed instruction, or PI, to incoming faculty, and provide external opportunities for additional learning opportunities if they are desired. This is not your traditional PowerPoint presentation. On the main menu, you will see instructions for navigation as you move through this presentation. One arrow will move you forward. Another arrow will move you backwards. The Home button will return you to the home screen. A blue button, when present, will allow you to choose additional options. You may press Escape at any time in order to exit the presentation. This presentation will be delivered online in an interactive PowerPoint format. Learning objectives and intended outcomes. Incoming Robert Morris University faculty candidates should be able to define programmed instruction, or PI, identify its history, which is its founder, purpose, function, and potential classroom applications. A brief lecture will identify the who, where, what, when, why, how, and other supplemental information regarding programmed instruction. This lecture will be limited to no more than 10 minutes in length in order to meet the predefined time parameters. Candidates will be encouraged to take notes, ask questions if presented in a live fashion, and provide feedback about programmed instruction while observing in an academic setting. Learning objective number 2. Class members will participate in a real-world example demonstrating the pros and cons of programmed instruction in a subject matter outside of general knowledge. For the case of this presentation, that subject matter will be nautical safety or boating safety. Simplistic in nature, class members should be able to replicate this task or example in any discipline in order to express the basic ideas of programmed instruction. Supplemental reading. No reading is required in anticipation of this presentation. However, a complete list of references and/or supplemental reading opportunities can be provided to students upon their request. Of course, this wouldn't be much of a live presentation without some form of assessment. Due to time constraints, the simplistic nature of the material discussed, and based on the spirit of the learning objective for this module, no written evaluation will be distributed to students for the purpose of this interactive PowerPoint presentation. In place of a written check on learning, students will be permitted to answer targeted questions as a group in an open discussion format following watching the presentation. This assesses understanding and has the added benefit of encouraging group interaction. Questions will include items such as: name the creator of programmed instruction, outline his background and a few other facts about him. Define programmed instruction. What is it? List the pros of utilizing PI in the classroom. Following that, list the cons of utilizing PI in the classroom. Identify PI uses outside of the traditional classroom atmosphere and recognize similarities and differences between PI and other educational disciplines. Programmed instruction was basically created by the famed behaviorist B.F. Skinner. Skinner had Harvard accolades and was well known in the areas of psychology, behavioralism. He was basically a jack of all trades in many facets of academia. The purpose of PI is to improve teaching, clear and simple. It's applicable to all levels. Some of the most common examples of it occur in pre-K through 12 applications. However, it's also very useful in higher education. It is based on the theory of verbal behavior as a means to accelerate or increase conventional learning. Programmed instruction has an extremely strong emphasis on self-teaching, where the student teaches themselves and moves on. It oftentimes includes specialized aids, such as textbooks, learning machines, and flashcards. Often used in self-directed study, PI can also be directed by a teacher, professor, lecturer, or something to that effect. Programmed instruction works to improve, add to, or augment the traditional classroom lectures. It can be easily modified for implementation in a flipped classroom model. It allows students to progress through a module of study at their own pace. They check their own answers and advance only after answering correctly. Programmed instruction is often used in pyramid-style learning. After completing a step, students can be exposed to an assessment to check their learning and comprehension before moving on to a more complex and advanced tier of instruction. This probably sounds familiar, and whether you know it or not, you've likely used programmed instruction in your own academic backgrounds. One of the most commonly observed forms of program instruction is probably memorization. So when a student's memorizing a finite number of facts, such as states and capitals or the periodic table of elements, American presidents, or whatever it may be, they're using programmed instruction. This is a great example of how flashcards can be utilized to impact upon PI. So as an example, the educator expresses a question which lies outside the realm of common knowledge. The educator measures the success or failure rate of that question. The educator then goes on to review the exact specific information using visual aids as needed, then retest the original question. At this point, the majority of the students should arrive at the correct answer, having been recently and directly exposed to the correct answer. So a great example of this would be something about boater safety. Now, of course, this wouldn't be applicable at a university such as the U.S. Naval Academy, but here at Robert Morris Institute, our cause is just fine. If I ask a student a question, so let's say you're heading upriver from a concert that was at Heinz Field, and you notice a buoy on the right-hand side. What color is the buoy? Now, obviously, I could expect a wide array of answers from the student regarding the color of that buoy. Most likely, they're going to spread the whole gauntlet: gray, blue, yellow, white, red. Suppose after the fact, I take that test, collect the results, and I would expect to have all sorts of different answers. I read a chapter from a nautical safety instructional manual, and in that nautical instructional manual it says that when a ship is in an inland waterway heading back to home port or upriver, buoys on the right side will be red and buoys on the left side will be green. Now, given that information, if I retest the original question and ask, you're heading home from this concert at Heinz Field, there's a buoy on your right-hand side, what will it be? I would expect to have near 100% come back with the correct answer, which is red. Now, the pros of this are very simple. They now have this knowledge of boater safety that they didn't have before. The downside is if I ask another question, so for example, you're in a boat, you're about to collide with another boat, and you want to lay on your horn to warn the other boat what's going on. How many beeps of the horn will it take to signal this warning? Now, there is a correct answer in nautical safety, and that correct answer is 5 short prolonged blasts. However, that's unlikely that the student would know that because it wasn't included in the original programmed instruction. So it's great for getting a finite amount of information learned. It's not so great when it comes to comprehension of an overall subject matter area. So the benefits of this are absolute comprehension over a limited amount of data. The downside of this is that it is not typically all-inclusive, as can be evidenced by the question that we just covered about boater safety. Programmed instruction has tremendous success in both industrial and military applications. At this point, if you have an internet accessible machine with an internet capability, I'd like you to use the following link to go out to youtube.com and watch the video. Under 3 minutes, it does an excellent job in explaining programmed instruction in a very, very easy to understand way. And I think it's a great way to supplement and augment this presentation. So please, at this time, pause the show, take a second to go to YouTube, and watch that video. When you come back, continue. Alright, I'd like to sort of assess your learning with a few questions, just one or two. I think this will also highlight some of the benefits to this type of presentation, computer-aided learning and interactive PowerPoint presentations. So the first question should be pretty simple at this point. True or false, programmed instruction breaks up information into small and easily digestible parts. So I can see that I put yes or no there instead of true or false, but does it do that, yes or no? If you believe that programmed instruction does break up information into small, easily digestible parts, please press the blue button that says yes. If you believe it doesn't do that, please press the blue button that says no. Great job. I can tell you were paying attention. Click the arrow to continue. Here's another question for you. Can programmed instruction work in any educational setting? Think very carefully about this one. It might be a trick question, wink wink. So if you believe it can, press yes. And if you believe it can't, press no. Heck, maybe you should be teaching this. You're doing a great job. Keep it up. You did a great job. I hope you had a good time and learned a little bit about programmed instruction. There's lots of resources available on the internet and through Robert Morris that can help you if you want to learn more. So please feel free to contact the Citadel at Robert Morris University if you'd like some more materials. This concludes the presentation. Thank you for interacting, and have a great day.
I'm sorry, that's incorrect. Please click the blue button to go back and try again, or you can press the home button to return to the beginning slide and review the information.